Hello, everyone. Welcome to the first live session of the course Experimental Biotechnology. I hope you are enjoying the course so far. And although it's still not, we have covered a lot of content, right? We have only gone to the, I think, second week or third week. So we have a lot of things to learn in this particular course, especially this course is meant for all the PhD students and MTech students who are either working in a laboratory or they are planning to go for research into their career. And if you have any more questions, if you have questions specific to the content what we have covered so far, you can post your questions. So far, there's no question available in the Google Drive except Google spreadsheet, except that few of the students are saying that how to prepare for this course for the final exam. So if you observe very carefully that I have prepared a course in such a way that it is more in a interesting way, so that you don't have to remember the protocols, because we are showing you the protocol also, right? Many of these experiments we are showing by the live demos, and demo videos are very elaborated, so you can be able to see each and every steps. And once you see the each and every step, I think it would not be you don't need to remember actually or memorize them. Definitely, there are technical points, there are technical terms, what you are supposed to remember and what you're supposed to learn. But these are the part of every course. Every course has some technical part or theory part which you have to remember. But in the NSEM, it is going to cover the content what you are already been, answering actually. So it's all going to be from assignments, and there are some questions which will be more on the experimental basis and so on. So in the NSEM exam, there will be questions which are going to be related to the assignments. There are questions which are going to be related to uh, the theory, and then there are questions going to be related to the some of the experimental design and all that. So overall, it is actually going to see that what you have learned by going through the content of this particular course. And there are 100 questions what you are going to attempt in this particular course, and there will be a 3-hour course. And there is no negative marking, so it is advisable that you should attempt all the questions so that you will be able to get the passing marks. The passing marks is going to be decided not only by the NSEM exam, but also by the assignments. So you have to clear the assignments, and as well as you have to get the satisfactory performance in the NSEM. Then only you will be eligible to get the certificate from this particular course. But I am hopeful that you will do better, and you will not only going to attempt for the certificate, but you will also going to look for the silver and platinum certificates as well. So, and if you have not registered for the exam, probably you should register for this particular exam, so that you should be get benefited. The certificate, we are not providing the hard copy right now, so we are providing the soft copy of the certificate, which you can actually be able to conveniently be stored into your hard drive, and you can actually be able to share that with your future employers, or you can be able to use that for showing that you have the experience of or skills of having this particular type of work. This course is good for all the PhD student or the aspiring PhD students. So if you have questions, this session is not very long. It is very limited session. And if the students are not there or questions are going to be over, we may actually we may actually conclude the sessions even before also. Deepika, do you have any questions? Deepika, if you have any question, just type your question and then I'll be happy to answer your query. Okay, good. So you don't have any question. It's just for one-to-one interaction. So you are doing PhD in what is your topic of the PhD? What is the topic of your PhD? And the institute. So Shrutika is asking about what is the difference between the urea page and the native page. So let me share my screen and I'll be able to understand. I will explain. So do you see a screen now, right? Okay. So the differences are very clear. Okay, and I'll only going to tell you. I assume that you know actually what is the urea page and what is the native page. Okay, so urea page or the native page. First of all, you remember that both are non-denaturating. Okay, which means they are actually not going to affect the covalent bonds. Okay, it means they are not going to affect the covalent bonds. The urea page, you are actually going to use a gradient of urea in the acrylamide. Native page is the page where you are not going to have any SDS and you are not going to have the beta mercaptoethanol. Okay, so if you don't have either of these, then it is going to be called as native page. And this is also non-denaturating gels, right? So it's not going to affect the 3D structures and all that. And then, so regarding the urea page, you are going to have the gradient of urea. So you can have the step gradients or the linear gradient, which means you can have 0 to 8 molar linear gradient, or you can have the step gradient, which means the well number 1 is going to be 0, well number 2 could be 1 molar, 2 molar, 3 molar, 4 molar, 5, 6, 7, 8. So it can be 1 molar, 2 molar, like that. Okay, so it can actually go the gradient in this direction, or it actually can go the gradient in this direction. Sometimes you're going to have the linear gradient. So 0 would be on the top and 8 molar would be at the bottom. Okay, so either way, it can be done actually. Either you can have a gradient this way or you can have a gradient this way. The end result is going to be the same, that you are actually going to be able to determine. So with the help of the urea native page or the urea page, you will be able to determine the you will be able to determine the oligomeric status of protein, for one, And you can also be able to check the stability of the protein, okay, with the help of urea page. In that native page, you will be able to determine the activity of the enzyme of the protein, if it is an enzyme basically, and you can be able to check the oligomeric status. So for that, you cannot use only the native. You are also going to use the SDS page, and oligomeric status would be the molecular weight in native divided by molecular weight in SDS. Okay, so it is going to be a whole number. Remember that it's not going to be a partial number because oligomeric status is always been a whole number, right? This means you can actually have the dimer, you can have tetramer, you can have like that. Okay, it cannot be in between. Okay, and apart from that, both are having the similar kind of thing. Okay. So Shrutika, did you have any other queries apart from this? Okay, so we have another question which is saying that if I want to take the highly viscous liquid, and I think in my video I said that you have cut the tips, right? So the see the amount of volume what you are actually going to suck when you are going to use the micropipette, it will be equivalent or will be comparable to the amount of air uh, you are actually going to suck, right? It's not about the length of the pipette. It's not about the length of the tip actually. So even if you cut the tip, uh, it is not going to affect the amount of liquid what you're going to suck. So for example, you have a tip, like cut the tip from here. This, if you think that this area, the liquid what was there in this area may not be now be countable, but it's not. If you cut the tip here, you are only helping the pipette to suck the liquid because it is viscous liquid. It is actually going to, it requires more pressure to, to suck it, right? So that's why if you cut this, you are going to have a, a diameter which is bigger, right? And if you remember the Bernoulli's theorem, right? If you have a wider tip bore, you require lesser force, and that's why it will be actually going to suck. So if I suck the suppose 300 microliter, if I don't have this, actually if I have only if I have a tip, right, then it will come here because this is the 300 microliter, for example, like this. Okay, so it is going to feel like this. But if I cut the tip, then it is actually going to fill the liquid up to this. Okay, so amount of liquid what is going to suck is actually equivalent to the amount of air what it actually going to suck rather than the the shape of the tip. The second question, so Shrutika, you can ask me whatever the question you have. Shrutika, please type the question which you want to ask. Okay, so what she is asking is which electrophoresis can be used for studying the protein-protein interactions. You can use the native page. I think we discussed about the native page, and you can also use another type of approach where I think that also we discussed, right? If the three-dimensional structure of protein is not involved in protein-protein interaction, then what you can do is you can also use another approach, okay? Which means only the smaller portions, like a portion of the protein is involved, but not the complete protein. Then what you can do is you can run the protein A. For example, you have two proteins like protein A, and you have a protein B, right? So you can run the protein A onto a SDS page, okay? And this I think we have discussed in when we were discussing the and so you are going to get a band here, right? Then what you can do is you can use the protein B just like antibody, right? So then you transfer this onto a nitrocellulose membrane. So you can transfer that. So it is actually going to be transferred onto a nitrocellulose membrane, right? And then you add this protein B, right? So what will happen? The protein B is actually good. Let me change the color actually. So will be much easier, right? So this is the protein B, right? This is the protein B, this red one. Okay. So what will happen is the protein B will go and sit here. So this is the A, this is the B, right? Now what I'm going to do is I am going to do a Western blotting with NTB. So at the end, what will happen? It is actually, if the B is interacting with A, it is actually going to give me a intense band. So this is going to be a band which is corresponding to B. And I know that the location of A is also this, right? Or I can do like Western blotting with NTB, and I can also do a Western blotting parallelly with NTA. And if I get the band at the same position, then it will actually going to say that these two proteins are interacting with each other. So Shrutika, is it clear now? So I think Radhika is asking about, please explain the Henderson-Heisenberg problem asked in the assignment. So which assignment I have given that question? Which assignment? Assignment 1 or 2? Which assignment we have asked the questions? So are you asking about the assignment 1, the question number 8? Please clarify, otherwise it will be very difficult for me to answer all the questions what are present in the assignment 1. Uh, the other people, if they have any questions, they can ask me the questions now. This session is very limited, so you should take the advantage of using this session for clarifying your doubt, because you will get benefited. Although we have the regular problem solving session also, so that also is be useful for you. But if you have any specific questions, I have already explained a couple of questions to you, right? And I only explained what will be the format of the exams and what will be the format of the assignments and all that. So if you don't have any more questions, probably we'll wind up the sessions much sooner than the scheduled time. Question number 14, right, Shrutika, right? Question number 14 is very simple because I think you are going to use electrophoresis system, which should be capable of separating the negative and positively charged protein together. So out of these given options, the first option is urea page, second option is gradient urea page, the third option is native page, and the fourth option is horizontal page. So urea page cannot actually differentiate between the negative and positively charged proteins, because the urea page either can take positively charged proteins or the negatively charged protein, not together. Okay, so it cannot be able to have the ability to separate the the proteins based on their charges. Similarly, gradient urea page or the native page also has a similar kind of limitations. Native page can be used for separating the complex mixture of either the negatively charged protein or the positively charged protein. But when you are having them together, it is difficult to separate because of the simple limitations that the electrodes are present from the the negative side to positive side. So you actually can flip the electrode and you can analyze the positively charged protein also. But when you analyze the positively charged protein, the negatively charged protein will not migrate. So in that context, when you are actually having the horizontal page, The horizontal page has the loading in the middle of the gel, right? So the proteins will have a horizontal page is a combination of native page and the agarose jelly electrophoresis. So in that one, when you are going to load the protein in the middle of the well, they have the flexibility to go either towards the positive electrode or to the negative electrodes. So the negatively charged protein will migrate towards the positive electrode and the positively charged protein will migrate towards the negative electrode. And that's how you can be able to separate out the complex mixture of protein where you have the negative and the positively charged proteins. So the correct answer is D. I'm not sure whether the due date is already been passed or not. So because that I have not remember, but I think the due date is already been passed. But that is the correct answer, D. Do we have any more questions? Otherwise, I think we'll wind up in another few minutes. So we are going to wait. I'm going to wait for another 30 seconds before I will conclude the following sessions. So if you have any specific questions, you can ask me. Otherwise, we will conclude this session. So Sukumar is asking about the question 6 and 8 in the assignment 1, right? What is 6? Okay. In the reaction given below, identify the conjugate acid for the base ammonia, which dissociates in buffer system. Okay. So I'm sure you are actually you are completely aware of that what is acid, the substance which actually gives the H plus ion is going to be called as acid, right? So in this particular reaction, if you are going to take the H plus ions from ammonium ion, then you are actually going to get the ammonia. And that's why the ammonium ions are actually going to be the conjugate acid for the base ammonia. Now for the 8 also, these two are actually related questions. So 8 is very much like based on the formula only. Okay, so you just follow the Henderson-Hasselbalch equation, and then the pH is equivalent to pK plus log the conjugated base divided by conjugated base divided by acid. Okay, so in this case, what you see here is that the nitric acid is having the conjugated base in the form of NO3 minus. So you are going to have the pH is equal to pK plus log base divided by the conjugated base divided by the acid. So in this case, the correct answer is A, that pH is equal to pK plus log NO3 minus divided by nitric acid. Okay, so is it clear, Sukumar? Okay, so we have another question from Kavita, how we extract the protein from the gel. I think we have discussed in detail how to extract the protein from the gel using the electroelution. And I think, I don't remember, but I think we have shown you a demo also in the experimental biotechnology, how to extract the protein from the gel. So what you are going to do is you are actually going to, where from whatever the gel you want to isolate the protein, what you can do is you can actually be able to what you can do is you can actually be, so suppose for example you have a gel, right, and this is the protein what you want to electroelute, right? So what you can do is just put this into a dialysis bag. I'm sure all of you actually know what is dialysis bag. So you can just put this acrylamide or agarose block into a gel, into the dialysis bag, and then you keep this dialysis bag within a horizontal gel apparatus, okay, where you are going to have the electrodes on both sides. So you're going to have positive electrode, and you are also going to have the negative electrode. It doesn't matter whether you keep it this way or that way because it hardly matters. Now what will happen is that the protein which is negatively charged, right? Remember this protein has the SDS bound. So it will actually going to migrate towards this side. Okay, so it will actually going to migrate from this side to this side. And when it migrates, it is actually going to cross the acrylamide barrier, and ultimately the protein will be present in this particular dialysis bag, because it cannot come out from the dialysis bag because the size of the protein will be higher to the pore size of this particular dialysis bag. So ultimately what will happen is that you're going to have the dialysis bag and you're going to have the block which does not contain the protein, and the protein will be outside. After this, what you can do is you can collect this into a beaker, right? And you can be able to recover this particular protein either by precipitation, or you can evaporate and collect the proteins from this. So this is just a simple overview of how you can be able to calculate. I think I have already, Vasudevan, I think I have already explained the question number 14 from assignment 2. So I'm not going to repeat that. We have already explained and we have already discussed the question number 14 from the assignment 2 actually, which I think Shrutika has asked before. So maybe you can just go through the recording and you will be able to understand what we were discussing. So I think if we have no more questions, I think I will going to wind up this particular session. And I am happy that you all attended the session and you asked some of the important questions and clarify your doubts. And we are going to have, this is just the beginning of the course. So in the next session, probably we are going to have many more excitement from your side, and you will actually be going to be come up with more number of questions, so that we are going to have more fruitful interactive discussion. So with this, I think I would like to conclude the current session, and we are going to see you next month in the live session 2. And I wish you all the best for clearing these assignments. And if you have any doubts, you can actually be able to post the doubts into the discussion forum. And I am very prompt in responding those doubts. So whatever the questions, if you think that it is a silly question, it is not worth it, so you don't have to worry about that. It is actually the all the queries what you are asking is actually maybe silly for your point of view, but it may not be very silly for others. So you ask whatever the question you have in your mind, and I will be happy to answer as many questions as possible. And in fact, I would prefer that you ask the question rather than keeping the confusion with them. Okay. As far as the last question, I think uh, the Kavita is asking whether we should memorize the protocol. So I think nobody should memorize the protocol, because it's memorizing the protocol is a very difficult task, and you are not going to get even the question also. What will be the step number 6 in southern blotting, or what will be the step number 4 in something like that in the NSEM exams? What we are going to ask is the main philosophy of using the different steps. For example, in the subsequent videos, probably you will see the lectures about the plasmid isolations and so on, right? Or you are going to see the videos related to cytokine arrays and other kinds of things. So we just want you to that you should understand that at each step what is actually being done, rather than memorizing that particular step. So because when you remember that what is being done, probably you can be able to use the alternate reagents. You can be able to achieve the same results. So idea of this particular course is to make you more experimentally more robust, so that even if you don't have X chemical, you can be able to work out the protocol with the Y or Z chemicals. So with this, I think I would like to conclude the current session, and I'm going to see you next sessions. Thank you.